So we want to find the inverse of f of x equals 3 over 2x minus 1. So one thing we might do is replace the f of x with a variable. It doesn't have to be y. It's just one that we always kind of associate with x. Now we want to solve this for x. Well, anytime you got a denominator in there, best thing to do is multiply both sides by the denominator, get it out of there. Because those cancel. And now we got 2x minus 7y equals 3. Remember that our goal is to solve for x. So we like to get rid of these parentheses also. So we will distribute this y. So we have 2x, let me start that again, 2xy minus 7y equals 3. Again, the goal is to solve for x. We're going to isolate it. So we're going to add the 7y to both sides. Gets rid of it over here. And what we have now is 2xy equals 3 plus 7y. We're almost there. We're just going to divide by the y, but I'm going to rewrite it up here. So 2xy equals 3 plus 7y. Finally, divide both sides by actually 2y, because we want, let's just do it all at once. 2y. Gets rid of the 2 and the y over here. And there's our inverse. But we want to find f inverse of x. So because we want our notation to match, whatever variable here we have to use in our function. So 3 plus 7x over 2x. Okay, so now that we want the domain and range of f and f inverse. So over here we're going to do the domain and range of f. Over here the domain and range of f inverse. The domain, let's start with just the domain of f. We know from what we know about rational functions and just functions in general, the denominator cannot be 0. So 2x minus 1 cannot equal 0. And we'll solve this for x. So we'll add 1 to both sides. We get 2x cannot be 1, and we'll divide 2. So x cannot be 1 half, excuse me. So the domain in interval notation is negative infinity up to 1 half, and union that with 1 half up to positive infinity. Now here's what's really cool about inverse functions. The domain of f is the range of f inverse. So I already know this range is negative infinity to 1 half, 1 half to infinity, because this is how they're related. Similarly, the range of f is the domain of f inverse. So instead of trying to find the range of this function, let's just find the domain of our inverse. Well, 2x cannot equal 0, which means x cannot be 0, is its domain. Basically all reals except that. And in interval notation, negative infinity to 0, 0 to infinity. And so then we also have our range of f. So that's one nice property that allows us to find the range of f very easily if we have the inverse of f.